for the coverage, for your midterms, the topic would be torsion. So we are done with the stress and strain. The next important topic under the strength of materials or deformables is your torsion. So before we start, I will be defining torsion muna. So torsion actually is the twisting of an object caused by a moment acting about the object's longitudinal axis. So taken this figure as an example. So we have here a circular shaft connected here sa natin A. So if an object is subjected to a moment along its longitudinal axis, yung x-axis na ito, tapos nag-apply tayo ng moment along the longitudinal axis, so the twisting of this object is what we call your torsion. So if applied with a moment, so ang tawag doon sa pag-twist ng object is what we call your torsion. Now, yung torque naman na tinatawag, that is the moment applied. So yun yung difference ng torque and torsion because most of the time students tend to interchange yung dalawa. So torsion is the twisting of the object caused by the torque. So the torque is the moment applied to twist the member. So yung moment mismo is the torque. The act of twisting is what we call your torsion. So all throughout naman ay examples ng objects na subjected to torsion is, for example, vehicles wheels. Kasi any type of an object that has a tendency to twist if applied with a power is under your torsion. Example, yung wheels ng car, di ba? Power is applied tapos nag-rotate yung wheels. Another perfect example would be wind turbines, So it generates power, di ba? Kapag habang nag-rotate yung sa wind turbine natin, nag-generate siya ng power. So all throughout our discussion, so we have here simplifying assumptions. First, we have circular cross-section. So circular cross-section. So why is that? Diba, circular cross-section, ibig sabihin, circle lang all throughout yung object na i-discuss natin all throughout the discussion. That is because yung circle yung cross-section, that is what we call as axis symmetric. So, tingnan natin. Ito drawing. Kunyari, ito yung circular shaft, So, kasi kapag nag-apply tayo ng, say, torque, so this will cause a twisting. So, for example, ito yung meron tayong mga lines, So, mag-twist siya, It just so happens kasi that if the cross-section is circular, we can say that it is axis symmetric. Ibig sabihin, although the object will rotate, the cross-section, if you cut it about any portion, the cross-section will remain the same. So even though subjected to twisting yung object natin, if you cut it at about any point along its longitudinal axis, we will have the same area. But if, for example, yung object na i-consider natin is, say, rectangular, tapos ito-twist ko na, na-twist natin yung rectangle, twist tayo. So, if the shape is not circle, na kunyari rectangle siya, if we try to cut it, yung area ng cross-section will not be equal. So, this is what we call as non-axis symmetric. So in comparison kasi for a circular cross-section, the analysis for objects that are not axis symmetric is significantly more complicated to analyze. So yung assumption natin all throughout our discussion would only fall on circular shafts. Kasi mas madali yung pag-analyze natin sa kanila kasi nga about any point, equal lang yung area yung i-consider. Unlike unlike your rectangle, your triangles, etc., very difficult yung pag-analyze. So, hindi lang simple application. Most of the time, mag-i-integrate, mag-i-integrate tayo no, for the area. So, yan. One thing to consider, no? So, all throughout our discussion, we will only be considering objects that are circle and cross-section, no? Kasi mas easier yung analysis. So first, the cross-section remains plane, no? And the perpendicular to the axis. The cross-sections do not deform. So kasi if masyadong malaki yung moment na i-apply natin, kunyari ito din yung circular shaft, if masyadong malaki yung moment, no, may tendency naman talagang mag-twist to na magkakaroon siya ng deformation, no? So, hindi natin, yung analysis natin for the discussion, no, it will not apply those with very large torque, no, which will cause deformation. So, i-assume natin na all throughout this lecture na hindi nagdi-deform yung cross-section. Tulad ng sabi natin, constant yung cross-section if we cut natin siya about any point sa circular shaft. And then the distance between cross-sections do not change. No? So the actual normal strain is 0. So the actual normal strain is 0. No? So ano yung i-consider natin? Bakit wala tayong normal strain? Di ba recall, definition ng normal stress, no, is the force over the perpendicular area. Now, in this case, the force applied is a torque or a moment. So, if mag-slice tayo, say, nakikita nyo tong part na to, if i-slice natin siya, so, ito yung area. So, the area, if you notice, this is parallel to the direction of the torque. So, the stress or type of stress that we are considering for objects subjected to torsion is more inclined with the analysis for your shear stress. Kasi nga, the area we are considering is parallel with the direction of the force, which is, in this case, your torque. Now, so to derive for the equations to be used here, we will cut it, for simplicity, no, we will cut a portion. Ito nga hinighlight yung portion. So we will cut it. Instead of distance L, we will have a distance dx. No? So, sorry, I forgot to mention. So, ito no, before the torque was applied, we have this straight line AB. Ito, straight line AB. And then after a torque is applied, no, mag-twist siya. So, from point B, mapupunta siya dito sa B prime. And then this dash line here is the new position of the straight line. No? So ito yung magiging deformation caused by the torque. So as you can see, we have here the angle between the original position to the new position is your theta. We're calling it as your angle of twist na tinatawag. I will show you later on yung equation for that. And then we have the radius of the circular shaft. So, yan. So, tingnan natin, we will get this cutted portion. It will be here sa next slide. Ayan. So, instead of L, we have the length of the portion as your dx. And then the distance from the original position, CD, and then yung dash line is the new positions. So we have here D prime. So the angle there will be your strain or shear strain na tinatawag. Diba? Strain, the formula for strain is the deformation divided by the length. No, so, as you can see, no, kung isusulat natin siya manually, so, yan. So, we have here tangent of this distance, no? So, that is d prime all over the length, which is your dx. Now, so if you notice, this dd prime is arc length, diba? So, the formula for your arc length is the rho, kasi rho yung ginamit natin na radius times the angle, which is your d theta. So, we will replace this with rho d theta all over dx. So, ito na siya. So, the shear strain, no, is equal to d theta over dx. Now, this is in terms of the segment of the entirety of the circular shaft. So, if we want to represent it as the whole circular shaft, palitan lang natin ng d theta, gawin natin theta, then rho or r, no, depending on the problem, and then dx will be your length. So, this will be the equation for your shear strain. Now, for the shear stress naman, for the shear stress, kapag this will represent, no, the shear stress. So, let's have here, yan. So, as you can notice in this figure, no, so this is since we have here the torque, no, so the shear of the angle of the area of the circular shaft, no, is largest, no, dun sa edge ng circle. So actually, we have two types of circular shafts. We have this solid, no, solid circular shaft and a hollow circular shaft, yung may butas. So in theory, no, it is actually safer for hollow steel shaft because kung hollow siya, ibig sabihin wala tayong stress dito. So, lesser yung stress dun sa centroid ng object. So, you will have smaller shear stress compared to a solid circular steel shaft. So, yan. So, so dito pala, no, hindi ko pa na-introduce, we actually have what we call your polar moment of inertia. So, the polar moment of inertia is, it describes the cross-section's resistance to torsion, no, because of its shape. So, it represents etong area. Now, this actually represents your polar moment of inertia. Ang polar moment of inertia natin is J. No, so, substituting this here, ito yung lalabas. D theta dx is equal to T over GJ. So, in this case, ang again, yung d theta natin, it represents your theta. Yung dx represents your L. So, we can rewrite this now so we can have the equation for your angle of twist. So, theta is equal to TL over JG. And then, another equation naman for your shear is T times the rho over your J. So, I have here the angle of twist. So, this was derived earlier. So, ito yung symbols and notation. No? So, for T, this is the torque. This is Newton millimeter. Bakit? This is moment, diba? Moment is equal to force times the perpendicular distance. So, ang unit is Newton millimeter. Angle of twist should be in radians. Anong ibig sabihin ng in radians? So, if you're going to use this equation, the theta here should be in radians. So we also have your polar moment of inertia, and then the length, mm, then modulus of rigidity, megapascal, maximum shearing stress, megapascal, shearing stress at any fiber, and then radial distance of any fiber from the center, rho. Uh, then, so ito yung equations earlier, no? So, shear strain, shear stress, and then angle of twist. So, as I have mentioned, no, yung tinatawag natin na polar moment of inertia, it describes the cross-sectional resistance to torsion. So, since, as I have mentioned, we will only be dealing with circular shaft, so, pwedeng i-rewrite natin to in terms of polar moment of inertia of circles. No, kasi since dependent to sa cross-section, so dependent to sa shape. No? So since ang shape lang naman ay i-consider natin is a circle, so ito siya. So this will be the polar moment of inertia for say a solid circle, and for a hollow circle we will have this equation. So substituting it sa shear stress is equal to force over area. Hindi, sorry. Substituting it here, sorry, dito. Ito. Yan. Substituting dito, no, we will have this equation. No, so, this will be the equation that we will use all throughout our discussion, since, as I have mentioned, we will only be dealing with circular objects. Circular and cross-section. So, ito po yung gagamitin natin, no, not the general one. So, saan natin to ito no, very important din to, no. So, we have different values of J depending on the shape of the object. So, kung rectangle siya, iba yung value ng J. Kung triangle siya, iba yung value ng J. So, I think you will encounter that pagdating nyo sa design subject, in structural design subject, because there are analysis where we need your polar moment of inertia there. So, dun lang siya may introduce. But for our discussion, we will be focusing on circular lang. So, ito lang yung i-introduce natin. Yan. So, I think that's it, no, for the equations. So, yung relevant equations are the angle of twist, TL over JG, and then these two equations, no, for your shear maximum. I will also be introducing another equations na, but later on na siya after ng example. Yan. So, polar moment of inertia and maximum shearing stress. Yan. So, let's have an example. So, a hollow steel tube has an outside diameter of 220 mm and inside diameter of 200 millimeters. Which of the following gives the maximum torque that it could carry if the allowable shearing stress is 75.5 megapascal? First, no, again, when solving, you need to take note of the given first. So you have your D, diameter. You also have the torque. And then you are asked of the allowable shearing stress. Allowable shearing stress. So shearing stress, no, is equal to 16T over yung J natin. So, but before that, before natin siya ma-solve, check natin yung equation. Yan. So to get your maximum, sorry, ang tinatanong pala is yan, tama pala. So, direct substitution lang siya, no? Kasi we have the torque and we also have the diameter, so direct substitution siya. So, pakita lang natin yung units. So, as I have mentioned, your torque is the moment, so it should be Newton millimeter, diameter in mm, the outer diameter mm, inner diameter mm. So, the final answer will be Diba? So, mm. So, Newton millimeter squared. The unit for your final answer is megapascal. So, checking now. So, yun. So, your T, direct substitution lang, we can get the value of your T. Yan. So, ito, simple example lang yun, no? Wherein we are doing direct substitution. And then, next naman, what is the minimum diameter of a solid steel shaft that will not twist through more than 3 degrees in a 6-meter length when subjected to a torque of 12 kilonewton meter? So what is the maximum shearing stress developed if your G is equal to 83 gigapascal? So, unang tanong is the minimum diameter of the steel shaft, no, considering the angle of twist. So, unang gagawin, 'di ba? As I have mentioned, look at the given. So, we have your angle of twist, we also have your length, we also have your torque, and then your G. So, if we write the equation for your angle of twist, it is theta is equal to TL over JG. The only unknown will be your J. Diba? J is equal to the polar moment of inertia of a circle. So, by substituting the polar moment of inertia of circle, we can actually compute for your diameter. Diba? Tingnan natin. So, ito yung equation. So, pinakita ko lang ulit yung unit. So, T is Newton millimeter. Length should be in mm. The J should be in mm4. And then, your G is Newton millimeter squared. Tingnan natin, Newton, squared, tapos squared sa taas, squared. So, the answer will be unitless or in radians. So, substituting the values, let's see. Isa-isayin natin. Yeah. So, for your theta, we have here 3 degrees. So, yung 3 degrees, no, i-convert natin siya into radians. So, magiging 3 pi over 180 yan. For the torque, that is equal to 12 kilonewton meter. So, let's sulat natin. 3 pi over 180 is equal to the torque, 12 kilonewton meter. So, kilonewton, convert nyo sa newton. So, what times 1,000. Meter, convert nyo sa mm. So, times another 1,000. So, lagay na lang natin 12 times 10 raised to 6. So, dalawang 1,000, 10 raised to 6. And then, your length is 6 meters. Again, convert it into mm. So, times 6,000. And then, your J. J for circle, I think, yan. The J for circle is pi d raised to the 4th over 32. So, pi over 32 d raised to the 4th. That is the only unknown. Now, for your G, we have Newton mm squared. We have your 83 gigapascal. Again, gigapascal is kilonewton mm squared. Now, since we want Newton mm squared, all we need to do is multiply this with 1,000. So, instead of 83, we will have here 83,000. So, rewriting this, you will get the value of your D. Yan. So, check natin. Ayan. So, your D is 114 mm. Now, you are also asked for the maximum shearing stress. So, provided by this equation, 16T over pi d cube. Nakuha na natin yung D, direct substitution ulit. So, we have 16T. Again, T should be in Newton millimeter. So, 16 times 12 times 10 raised to 6. And then pi times 114 cube. So, your answer will be in Newton millimeter squared. Magka-megapascal yung sagot natin. Yan. So, 41.25 megapascal for your shear maximum. So, when solving, as I have mentioned, ang dapat unang-unang ginagawa nyo is look for the given, then write down the possible equations that you can use, no? Kasi there are times that gagamit tayo simultaneously ng two equations for us to solve the unknown. Yan, have this naman. So, a solid steel shaft shown is loaded as shown. So, using G is equal to 83 gigapascal, determine the required diameter of the shaft if the shearing stress is limited to 60 megapascal and the angle of rotation at the free end is 4 degrees. So you are asked for the required diameter, but we need to consider two things. Una, what would be the diameter considering the shearing stress, which is 60 megapascal, and then what would be the diameter considering the angle of rotation or the angle of twist, which is equal to 40 degrees. So we will use the two equations, no? Diba, dalawa yung equation, angle of twist and shearing stress. So before we can do that, since this is a cantilevered circular shaft, no? Diba, recall sa statics nyo, since this is cantilevered, obviously this will have a reaction. So konting recap tayo sa statics. Diba, what is the purpose of reaction? Ba't tayo may reaction sa support? So we have a reaction or yung support reaction natin is there to avoid movement. No, yun yung purpose ng support, yung hinge, roller, fixed support. Ang purpose nila is to avoid movement because we want our object to be in equilibrium. Ibig sabihin, if we add all of them, no, summation of forces X, summation of forces Y, summation of moments about any point, everything should be equal to 0. Kaso anong ibig sabihin pag 0 siya? Ibig sabihin pag 0 siya, equilibrium, walang movement, at still yung object. Kasi we don't want our structure to be moving, di ba? Ayun yung gumagalaw yung structure natin. Kaya tayo naglalagay ng support, no, para stable siya, para safe. So if yun yung idea, no, dapat in equilibrium. So if alam mong ganun yung idea, mas madali lang yung pag-compute mo ng reaction. So without having to use the equations of equilibrium, no, just by looking at the problem, masasolve mo agad yung reactions. Tulad nito, we have a 1, 2 na counter, tapos we have 750 na upward. So, as I have mentioned, no, dapat equal sila. So kung 1, 2 to, ito naman is 750. So kulang tayo ng 450 para yung total nung clockwise natin is also 1, 2. So ganun lang. Pwedeng gawin nyo by inspection, we can say that the reaction at A is equal to 450 because 450 plus 750 is equal to 1, 2. Thus, makakancel na nila yung each other, no? So in equilibrium na yung system. So again, that's just a recap, no, of your statics, computation of reaction. Kasi very important kasi, no, na hindi lang kayo nag-solve, dapat naiintindihan nyo yung ginagawa nyo. So, yun yung concept behind, no, in computing your reactions. We just want everything to be equal if added. So, yeah, 450 plus 750 is a clockwise rotation. And 1, 2 is a counter, so they will cancel each other out. So 0, walang movement. So safe yung ating structure. No? So just in case you want to write it down, no? So ganun lang naman siya. So the reaction at A is 450. And then we will have what we call your torsion diagram. No? So it will just represent the torsion that is present on your circular shaft. So at A now we have 450. So all throughout here, since wala namang moment present, no? Ito lang yung moment, so there's no change from A to B. So constant yung 450 natin Constant yung 450. After a 450 was applied at A, no? Continuous siya all throughout AB kasi there's no moment present here that will cause any changes, no, from A to B. But from point B, we have an additional 750. So from 450, add tayo ng 750, umakyat pa siya. So this will now be 1, 2. Then again, B to C, there's no moment present. So constant 1, 2 yung torsion from B to C. Then at point C, ito na yung counterclockwise natin, 1, 2. So it will revert back to 0. No? So this is the visual representation of the torsion that is present on this circular shaft. So 450 yung A to B. And then 1, 2 naman yung ating B to C. So you may just draw the torsion diagram like this, no? Or you may also write parang ganito. So why is this important? No, because this visualizes the torque that is present sa A saka sa B. Bakit siya important? Because, di ba, we need your torque in solving for your stress or your shear stress. So, yan, solve na natin. Since we have already established the reaction and the torque diagram, we can now solve for the diameter. Yan, so using the, yan. So, we have, again, we will consider two things, no? First is the, yan, is the shear maximum. The second one is due to the angle of twist. So in this case, balik ko, sorry. So in this case, no, equal naman yung length ng AB and BC, which is 2.5. No, so your L is equal. Yung diameter niya, no, wala namang sinabing non-prismatic siya or uneven yung cross-section. So i-assume natin na equal din yung diameter. So in solving for your shear maximum, you may just use you may just solve it once. Normally kasi no normally kasi isa-solve niyo siyang twice. So ano yung shear sa AB, ano din yung shear sa BC. But in this case kasi since equal naman yung distance and then we are assuming for the circular shaft to have a constant diameter, kahit yung isa na lang isolve natin. Well, obviously, dito sa figure, yung BC yung may mas malaking torque, so we will use the section BC. So, substituting here the value, 16, ang ting gagamitin natin is 1,200 because that is the maximum shear. Then pi times d cube. So, 60 megapascal is the limit or the allowable shear stress. So, Dex substitution. Ayan. Again, do not forget to convert, no? So we have 16. This is 1 to Newton millimeter. Remember, meter. So, convert natin siya into mm. Thus, we have here an additional 1,000. So, convert natin yung 1 to Newton meter into Newton millimeter. So, your final answer here will be in terms of mm. Yan. So, if we are consider your shear maximum, the diameter of the circular shaft would be 47 mm. Next naman is for your angle of twist. So, sa angle of twist kasi, we need to add the angle of AB and BC. So, summation lang siya ng TL over JG. So, also as I have mentioned, no, circular yung kanyang cross-section, the same yung G, and then the same yung length. So, pwede natin i-factor out itong tatlo. Factor out natin para mas madali. Yan. After na, T1 L1 over JG, T2 L2 over JG, then factor out natin for simpler solution, no? Pwede din na hindi, up to you, no? So, sinimplify ko lang po yung equation. Then, direct substitution. Yan na. So, again, do not forget to convert your degrees into radians. So, times pi over 180. 25 for the length. Pinactor out ko. Tapos J for polar moment of inertia of a circle, pi d4 over 32. Then 83,000. So, again, yung 450 tsaka 1, 2, convert natin into Newton mm. So, this will give us your D. So, your D now is equal to 52 mm. Now, so, since we have two values, no, of course, you only need to choose one. Kasi nagde-design tayo, no, hindi naman pwedeng dalawa yung diameter. So, if we are going to choose, would it be 47 or 52? Na? So, in choosing kasi, you need to understand kung ano ba yung ibig sabihin ng pagkuha natin ng diameter. So, ang ibig sabihin kasi nito, no, is for your shear max, no, for you to not exceed the allowable shearing stress, no, of this circular shaft, the diameter of your circular shaft should be 47 mm. So, ibig sabihin, pag lumiit ka pa sa 47, kunyari, ang ginamit mo is 46 mm, no, magkakaroon ka na ng failure sa shearing. So, in that sense, if you look naman sa twisting, ang required diameter for this circular shaft para ma-resist niya yung failure sa twisting should be 52 mm. Kapag bumaba ka sa 52, magkakaroon ka ng failure sa twisting. So, in that sense, no, ang gagamitin natin, of course, would be the bigger value, which is your 52. Kasi nga, pag bumaba tayo sa 52, sabihin natin 51 yung gamitin, magkakaroon tayo ng failure sa twisting. Now, so, since mas malaki yung 52 sa 47, of course, safe ka na agad sa shear. No? But if, say, ang pinili mo, use 47 mm, safe siya sa shearing, but it will not be safe sa twisting. Na? So, yun yung reasoning behind that, no? So, kapag ganito, no, pero hindi siya all the time, no? Depende siya sa mga problem. Baka pag naka-encounter ko yung ibang problem, ay palaging mas malaki yung pipiliin ko. So, that's not always the case. It depends on the problem. No? So, dapat kasi naiintindihan niyo yung reasoning behind para hindi kayo mamali sa future. No? So, yun yung reason, no? That, ito yung magiging limit sa design natin. So, we want our circular shaft to be safe against twisting. So, we will choose 52. So, greater than siya dun sa allowable sa shear. So, safe pa din siya. So, gagamitin natin, use the 52 mm. So, ano bang nangyayari? Kunyari, what will happen if nagkaroon tayo ng failure sa shear? Kung ito yung shaft, no? Pag nagkaroon kasi tayo ng failure sa shearing, mapuputol siya sa gitna. As in, straight na putol yung mangyayari. No? Kasi di ba shearing stress is force parallel. So, kunyari, ang ginamit mo is 45 or some less than the 47, no? There's a possibility that it will be cut in half, no? Yung ating shaft. So, yun namang twisting, pag twist naman, magkakaroon na tayo ng permanent deformation. Di ba? As I have mentioned kanina, kahit may twisting tayo, di ba, magiging constant pa din yung cross-section. Pero pag magkaroon tayo ng failure sa twisting, magkakaroon na siya ng deformation. So again, we want to avoid that because we want a safe section. Na? So yeah, that is, so yung problem na to, this is designing, we are asked to design this circular shaft, no? So ano daw dapat yung diameter na gagamitin natin if this circular shaft is applied with this given torque. No? So, pag-design natin, ito dapat po yung diameter ng circular shaft, which is 52. So, this is minimum, ha? Pwedeng lumaki dyan. That's okay. But this would be the minimum, the 52. So, to avoid failure. Yes. So, next naman, no, we have here what we call your the power transmitted by a rotating shaft. So, ito naman yung i-consider natin, no? If the torque is not available or hindi siya present sa problem, and then ang binigay is the power. So, ano yung power na transmitted by rotating shaft? Example nga, no, yung sa vehicles. So, yung power na ini-exert natin to have a torque, no, dun sa object, that is the power. So, if ang given sa problem is the power transmitted instead of the torque itself, we will be using this equation. So, we have the power in terms of watts, no? Hindi kilowatts, watts. It is equal to 2 pi times the frequency, which is revolution per second or hertz, and then multiplied by the torque in Newton millimeter. Newton meter, kilonewton meter, but in solving Newton millimeter. So yun, Newton meter or kilonewton meter. So, ito lang naman yung additional na equation that we need to consider. So, let's have a problem. Yan, a solid shaft in a rolling mill transmits 25 kilowatts at 4 hertz. Determine the diameter of the shaft if the shearing stress is not to exceed 50 megapascal and the angle of twist is limited to 8 degrees in a 4-meter length. No, so, bale, we are asked for the diameter. No? Again, almost the same to ng previous problem. Ito-consider ulit natin yung shearing. Dapat hindi mag-exceed ng 50. And then, hindi dapat, yung limit ng angle of twist is 8 degrees. So, bale, dalawa ulit yan. So, solve natin twice to get the diameter for both, considering allowable stress and then allowable angle of twist. So, before we do that, we don't have the torque. Ang binigay sa atin is yung power ng tinatransmit ng rolling mill. So, kanina, di ba, sabi ko P is equal to 2 pi Ft. So, the power is 25 kilowatts. So, convert natin into watts. Then, 2 pi. The frequency is already in hertz. So, times 4. So, yung T, no, ang unit ng T na lalabas dyan is Newton meter. Yung T, yung unit ng T. So, check natin. So, the torque for this solid shaft is 994.7 Newton millimeter. So, all you need to do is substitute that here. Substitute na lang natin. So, shear maximum is so 50 is equal to 16 times, ilan na nga yun? 994.7 Newton meter yan ha. So, times 1,000 para maging Newton mm pi dq. So, this will give us D. No, direct substitution. Ayan. So, by twisting, the same then, 8 degrees, convert nyo into radian. The torque is 994.7 times 1,000. The length is 4,000 mm. J is pi d 4 over 32. G is 83,000. So, direct substitution. 44 and 47. Again, no, we need to choose one. So, of course, we will choose the bigger diameter. Kasi yung limit ng shear is 47. Tapos yung limit ng twisting is 44. So, in this sense, no, mauunang mag-fail yung shearing, no, compared sa twisting. Kasi yung limit niya is 47. Pag bumaba ka sa 47, mag-fail na siya sa shear. So, use D is equal to 47. Yeah, so let's have another example. So, the steel shaft shown in the figure rotates at 5 hertz with 45 kilowatts taken off at A, 30 kilowatts at B, and 75 kilowatts at C. Using G is equal to 83 gigapascal, determine the maximum shearing stress and the rotation of gear A relative to C. So, dito ang tinatanong na sa atin, no, is what is the shear max? So, pag nagsosolve, tingnan nyo yung given. Next, no, ano ba yung tinatanong? So, you are asked for the shear max. Ano daw yung shear max? And then, what is the rotation of the gear relative to A to C? So, yung angle, no, from A to C. So, the angle of P. So, substitute lang naman natin, no? So, alam din naman na natin yung equation for shear max. Alam na din natin yung equation for angle of twist. So, the only unknown here will be your torque because you are given the power at each point but we do not have the torque. So, madali lang naman. All you need to do is solve for the torque. Diba? So, we have power is equal to 2 pi ft. So, pwede nyo na din itong i-rewrite na para mas simple. So, P, 2 pi f. Tapos, isa-isayin lang natin yan. So, for TA, so, P niya is 45. Diba, 45 kilowatts. So, 45,000 watts. Over 2 pi f. F, 5 hertz. I'm sorry. So, ganun lang. For TB naman, substitute nyo yung 30,000. Tapos, for TC, substitute nyo yung 75. So, we will solve the value of TA, TB, and TC. So, ganun lang. Yan. TB, TC. So, again, the unit na is Newton meter. So, you would still need to multiply it with 1,000 pag sinubstitute na natin. So, applying it now, no, so if you'll notice, if we add nyo yung 1432.4 plus 954.9, no, it is equal to 2387.3. So, ganito yung magiging itsura niya. No, kasi di ba we want our system to be in equilibrium. So, dapat babalik siya sa zero. So, ganito yung itsura. Ito yung torque present. Then, diba, after this, all we need to do now is draw the torque diagram. Sorry. Torque diagram, diba? So, aakit tayo ng 1432.4, constant from A to B. 1432.4 plus yung 945.9, so 2387.3, tapos pabalik pa ba. So, this will be your torque diagram. Yan. So since we have already established the torque diagram, no, pwede na natin siyang isolve direct substitution. Matira yung theta. Yan. So, unlike the previous example, no, wherein we have the same length, the same diameter, etc. Now, in this case, kasi, we have different diameter, different length, no, different torque. So, just to make sure we can solve for the maximum shear, we will solve it twice. No? Kasi, hindi ibig sabihin na mas malaki yung torque sa DC. No? Kasi, di ba baka, ay, ito yung malaking torque, ang isosolve ko lang is yung Tmax ng DC. So, since hindi kasi sila the same yung diameter, no? So, meron pa tayong isang variable na need na i-consider. No, di ba? Ang ating equation is 16t over pi d cube. Now, since we have different diameter, no? Of course, that's another variable to consider since you will have an effect, no, dun sa equation natin. So, we cannot just assume that the maximum shear stress would be at BC dahil lang mas malaki yung torque sa BC. So, ito yung sinasabi ko earlier, no, na if hindi constant yung ibang variable dun sa ating equation, just to make sure, no, we will solve it twice. So, solve natin yung AB and solve din natin yung BC. Check lang natin kung alin ba talaga yung maximum. So, first, for your segment AB, we have 16 times 1432.4 times 1,000 divided by pi 60 square cube. Sorry. So, we have 33.77 megapascal. Now, this is the shear for from A to B. Ito yung shear niya. So, remember lang, no, yung 1432.4, kinonvert natin into Newton mm. Next naman is the shear maximum for BC. Tingnan natin. So, 16 times 2387.3 times 1,000 divided by pi, 75 cube. So, we have 28.82. So, if you notice, no, the larger shear max is actually at AB, no? Yung sa smaller yung torque. So, yan. So, in this case, the final answer would be the shear maximum for this solid shaft is 33.7 megapascal. No, so, yan yung magiging final answer natin. No, so, yun yung sinasabi ko earlier, no? So, hindi pwedeng mag-assume tayo na. So, depending on the problem and on the given, no? So, kailangan din natin i-consider. Yan. So, next naman is the angle of twist. Yan. Angle of twist for this now. So, from A to C, we're going to add the angle of twist of AB and BC. So, the only constant here now is your G. So, G lang yung pinactor out ko. Since we have different values of L, different meters, so magkaiba din yung J, then different torque. So, substitute natin isa-isa. So, your torque here is 1432, length is 4,000, times 1,000 pa to. J is 5 pi d 4 over 32. So, substitute natin. Ayan. No? So, as you can see, direct substitution na ulit siya. Just be very careful. Ulit-ulit na ako, no? Be very careful of the unit, no? Yung pag-convert. Kasi po, if namali kayo ng unit, definitely you will have wrong answers by the end. So, always double check your solution pag nagsasolve kayo, no? So, there's no harm in doing a double, triple check just to make sure that you have the correct answer, no? Especially if ganitong medyo makahaba yung pag-input sa calculator. So, mistakes are often happen sa ganon. Yan, 0.073 radians. And then, of course, since this is radians, no, ang final answer natin, no, kasi theta mismo yung tinatanong, convert nyo naman siya ngayon into degrees. So we have 0.073. Now converting it into degrees, we have 180 times 180 over pi is equal to 4.17 degrees. Yan.